Can you guys hear me? Excellent. All right. Welcome to Python for Social Scientists. We are together until I believe 4:40, 4:30? All right, sounds good. So my name is Renee, and I have been a software engineer for 3.5 years now, but my original major was economics, and I loved history and the social sciences. And I think that a lot of people that don't come from a programming background sort of feel out of place when they try to learn how to program. So my intention for making this tutorial is to bridge that gap a little bit. I'd be so curious to hear about your guys' background. So if you wouldn't, before we get started, if you want to follow along with the notes, you can get to this GitHub repo from this bit.ly link. And on top of that, if you go to this URL, you can leave feedback for me. Can someone confirm that that's the right one? Let's see, tiny.com/yzfpby. YZF. Let's see here. YZFPBY. Thank you. Beautiful. Okay. So at the end of this tutorial, please leave feedback for me so that the Python organizers have data. So today we're going to work with Python together to clean up data, to manipulate new CSV spreadsheets into something that smart people like you can use to do some data science analysis. But this is mostly focused on the programming side of things, of getting data into a state where it even can be used. So I gave you guys my background, programming for 3 years. I still love NPR and the New York Times more than sci-fi and comics, for example. But while you guys are here, I'd love to hear a quick introduction of each one of you. What your program experience is, that'll help me gauge how fast to go, and why you're interested in learning this information. And I'll start with you.
All right. I have been programming Python for probably 5 years. I work at a university, and so I'm mostly doing work with student data and a lot of survey data.
Interesting.
Has some odd sort of requirements for it.
Very interesting. Thank you. And what's your name again?
Oh, John.
John. Okay.
I'm Patience. I'm a business reporter.
Awesome.
And I've been using Python for about, I guess, a year and a half. And I use it for different data analysis things or to build scrapers for data from my reporting. So I'm always looking for more ways to use that.
Awesome. Wonderful.
My name is Jay. I've been using Python for approximately 8 years. I work for Azure ESI, which is a mapping company. I mostly use Python for image analysis, like surface analysis, image classification, all this kind of thing.
Very cool.
My name is Steve. I'm also a program engineer at SAP, and I have been using Python for 2 years now. And I mostly work with raster data or raster analysis. What is so I use some sort of data before when I was in raster.
Sounds good. Okay.
My name's Adam. I've used Python for about 3.5 months. I'm school of programming,
Wonderful.
My name's Alan, and I've been using Python for just a few months, started this year, as well. But I work as a data analyst for a local health plan, actually from Portland. And so I'm interested in maybe using Python in my job and why not integrate that.
Wonderful. Wonderful.
My name is Abdul, and I work with John. I've been using Python for about 2 years, along with R. Along with R until a month ago. But
Wonderful.
Hi, Carlos. I'm working with yeah. I have been working with Python since 3, 4 years. Now I like to learn more and speak and apply Python
Wonderful.
Hi, my name is Jonathan. I have been using Python for about 2 years now. Doing a lot of work with financial data as well as geospatial data for like visualizations.
Very cool. ETL? Okay. Sounds good. Wonderful.
My name is Roderick. I'm a Cisco project knowledge extension. Unfortunately, have a lot of data. I like to participate in those data. And Python, I'm really doing very, very Python so far.
Mm-hmm. Sounds good. Yep. Sounds good. Sounds good. Sounds good. Sounds good.
My name is Rachel. I work for Oregon Health and Science University in their behavioral neuroscience department, and I've been using Python for about a year to help with both imaging and behavioral studies.
Wonderful. Sounds good. Go ahead.
My name is Renee. I went first started as a statistician. My background, I have a PhD in social psychology and statistics, and I'm fairly new to Python.
Very cool.
Steve Rosa, co-chair of the privacy and data security team at the law firm Holland Knight. I use Python to parse clients' network traffic.
Wonderful.
My name is Kayla, and I use Dropbox, network reliability, and then Python developer.
Wonderful.
My name is Dan, also with Dropbox, also reliability, and using Python for a couple of years, and mostly use it for payment automation.
Sounds great.
Greg Rogers, I work for a large firm with a lot of engineers, and so I'm using this for, I've been working with Python for over a year, and it's for time series data from operating system performance and applications and activity and response.
Sounds good.
Scott, been working with Python for about a year, and mostly using it for design.
Sounds good. Yep.
My name is also Scott. I work for the National Weather Service, and using Python for about 2 years for distribution purposes, analysis and forecasting.
Sounds good. Wonderful. Behind you guys? Wonderful.
Also James Sims. I work for a power company. We extract data and analyze results from our power plant.
Wonderful. Okay. Thank you. Thank you guys all for taking the time to do that. I'm really glad I asked because there's a bigger distribution of experience levels than I'm used to. There's some people that are pretty new to programming and have a strong social science or research background, and there's some people, it seems, that do some quite advanced programming. So I would ask your patience, those of you guys for whom a lot of this is old hat, and sort of sit back and think about the big picture of what we're doing. If anything of this seems easy to you, then I'd really encourage you to help others. And if this isn't easy for you and you like get off on something or you don't quite follow along, please be really just raise your hand really early, and hopefully someone else will be able to answer your question. And I'm also happy to answer questions on the big screen because I like a much more interactive format. So can we all agree to do that? Awesome, great. And also please take a minute to turn to the person next to you. Some of you guys already know each other. And please introduce yourselves to each other. So a lot of All right, so the reason why I'm asking you guys to introduce yourselves to each other is please let each other like copy off of each other's screens. It'll let us go faster. And a lot of times if people get thrown off, it's not because they don't understand something, it's just because like one character is off. So the more you guys can answer each other's quick questions, the more you can stay on track. And if you're in danger of falling too far behind, just raise your hands. Like seriously, that's not a problem. Cool, all right, are you guys ready to get started? Great, okay. So on the GitHub repo, I have all of my speaker notes, so you guys can follow along with what I'm about to say if you so choose and copy and paste the code from here. But you can just go to the GitHub repo to get the starter code to begin with, and I'm going to have you clone this GitHub repo into your own system. So go ahead and go to this bit.ly link here. And you'll do in your command line, you'll go to wherever you have your projects. So you might have a projects folder, you might have a code director. For me, it's in projects and documents projects. So if my code folder was here, I'd go into here and I would do git clone and I'd give it the oath. And I would do git clone of this entire thing. It's probably going to tell me, whoops, that it already exists. Cool. All right, so I already have it, but for you guys, if you do git clone of the GitHub URL, it should download all of this code into the directory you're in. Are you good? Yes. Okay. Yes. Yeah, this, I'm using Python 2 for this, so if you guys have Python 3, I think the only thing that should get affected is the print success would need to be a function, so that is a good point. The question was, if you have Python 3, will this code still work? And the answer is, I'm not exactly sure, but I know, for example, the print statements in here will have to be inside a function call. It's the print, yeah. The U? The RU? Okay. In that case, I would like to ask you to find out what the open statement on the first piece of sample code should be for. Oh, just R? Oh, great. Sounds good. Okay, so that'll come up in a minute when we run our first little bit of code. But just getting everybody to download the code, please raise your hand if you've successfully been able to clone the sample code. Cool, okay. And if you haven't, are you figuring something out, or are you just waiting at the moment? Have you been able to download the code?
I haven't.
You haven't? Oh, okay. What's going on?
I'm not quite sure.
Okay. What response are you getting in the command line?
I haven't got to the command line.
Oh, okay. Okay.
I'm having some
Okay. You're not able to open up terminal?
I can open it.
But the command line isn't going through?
Let me try.
Okay, cool. Is there anybody else that's having trouble getting the code? All right, raise your hand if you have the sample code downloaded. Okay, so it looks like we have a couple people that are getting help. We will go forward. Okay, so we have this code downloaded. Did it work? Okay. Okay. Let's see. All right. Okay. So the first thing you need to do is open up a text editor, the one that you normally use. Raise your hand if you don't normally have a text editor that's your go-to. Okay, so everyone knows which text editor they're using. Great. Next, you need to get the sample code and then clone in the directory, and now you should have Python for Social Scientists in your directory. So if you ls it, there's, oops. So if you look inside it, there is a starter.py file, a cheatsheet.md, which has the speaker notes that I'm using right now, and then a directory called data. So, okay, so this is the starter code we're going to use as well as the completed code for this tutorial. So let's look at what we're going to do. The scenario for this tutorial is we are all social science researchers looking at economic data for countries. So we care about how much debt a country is taken on, we care about how creditworthy the country is, and different factors that might influence their creditworthiness. The World Bank has a lot of really interesting data on countries. So if you were to go to the World Bank, where I got all this data was from this source here, and if I want to look at, for example, the income share held by the lowest 20% of an entire country, I could get that. Okay, this is something you guys don't need to do because it's already in the repo you cloned, but I just wanted to show you guys where we can get this from the internet. Looks like it's taking a long time though. Oh, here we go. So the World Bank collects lots of different indicators about development for every country. You can download them, and it goes back many years, but some years don't have fields. And so we downloaded some of these related to macroeconomic indicators, and they're in our code repo right now. So if we go to GitHub for this, for our code repo, for what we just downloaded, the data is downloaded in the CSVs here under originals. So credit ratings is not from the World Bank, it's from The Guardian. But if you Google for sovereign credit ratings, you'll get this spreadsheet of the countries and their S&P rating, Moody's, and their Fitch rating. So these ratings agencies rate bonds, they rate companies on how creditworthy they are, but they also do it on sovereign debt, on if the country itself is borrowing money. We have table of how much debt a country's in as a percentage of their GDP. So this country, Albania, has 35% of debt as GDP. The United States is like 100% or 98%, I believe. We can see it going down, and there's some spaces for blanks. But as you can see, when the World Bank gives you data, the first few fields are these extra rows of description information. And then we also have inflation, like how high inflation is per year across years starting from 1960 to whatever years have data. So this is the data that we're going to work with, and it's not exactly ready to do analytics on yet. And lastly, we have one file of data that's a little bit shorter than the others called sample.csv, and it's a subset from the other from one of the other tables, but it just has the name, the country code, and I believe that's the inflation rate for 2013. So that's what we're looking at, and we are going to manipulate it with Python together. Okay, so let's go ahead and open up your code. And the first file we're going to look at, the file that you guys are going to be editing, is starter.py. And it should have code that looks like this. And the first thing we're going to do is read it in. So if you go back to your command line and you say Python sample SAM, and then you hit STA starter.py, and you complete that, what it should do is should print out every row from that tiny little file. So what is that doing exactly? So what we're doing when we do that is we are all right. So all it's doing here is we're opening up the shorter CSV file. We're saying it give us read-only permissions. And then we say, OK, we use this thing called the dict reader, which will let us consume a CSV file and treat every row as a dictionary. So every row has a key, that's the column name, and a value, that's the value in the dictionary. And we say for every row in that whole bunch of dictionaries, print row. And so the first one was the United Arab Emirates, and it's saying the key is the country name, the value is this. Then the next column, the key is the country code, and the value is ARE. And then finally, the key is 2013, and the value is 1.9%. And then it does the same thing. We have the same keys because the same column names for the second country, Australia. All right. Does anybody have any questions on that? All right, sounds good. Okay, so, all right. So let's say we wanted to take advantage of the fact that we're using dictionaries, right? Dictionaries, you can reference a value by the key. So if instead of printing out this entire row, we wanted to just print out what the country code is, or what the inflation, what the 2003 rate is, in that case, what would we have to do to our sample code in order to only print out the values? Here. Row.values? Let's see here. Row.values, maybe? I'll go ahead and try it. Built-in. Ah. Oh, cool. So it takes the values without the key and it prints them as a list. Nice. Nice. And the way that I was doing it is I was doing it like if I want to look up just one of the values, like if I wanted to look up a year, I have them doing row dot row and then use the key, indexing. So I said I want to get row of country code. There. And that's giving us the country code that we're just calling. But yeah, you have the exact right idea. And then if I wanted to get the 2013 values for this, what would I do? Yeah. Cool. So that's printing out the same data here, but we're specifying which values that we need out of here. Sound good? Does anybody have questions on what we are doing right now? Cool. All right. Sounds like we're good. And are you, I'm sorry, what's your name?
My name is
Alan?
I'll get there.
You're downloading Git right now? Okay, sounds good. Okay. So when we're doing something like this, I always recommend that people just get comfortable with the data and look at it in a real spreadsheet first, just so you have a good intuitive sense of what's going on, and just even get practice like bringing it all into Python and printing out the rows just so that you have it before you try to do any sort of work on it. But now let's say we want to take that CSV that we have, and we want to do the same thing, but instead of with our little sample file, we want to do it with the entire det GDP percentage data file. So we want to do this same printout, but we don't want it to be sample.csv. Instead, we want it to be our other file. So in that case, what we need to change to do this same printout for our bigger file of data. Oh, yeah, exactly. So in here right now, so what this is doing is it's saying we're importing the CSV library, and then we're saying open, this is a Python keyword, open this file, which corresponds to this, data sample.csv. We're saying open that, and the F gives us a pointer to it. So we're not consuming the whole file in memory. Instead, there's this massive thing of data, and we have just this little piece in memory that's just pointing along to one point in the file. So that gives us the ability to read the file of data sample.csv. Then we take this, and we feed this, we assign it to the value of F, and we assign it to this class called dictReader, which lets us parse a file and treat each row as a dictionary. And then for each row in there, we are printing out what the row is. And then we go further and we say we just print a specific value from that dictionary. Does that make sense for those of you guys that aren't familiar with Python quite as much? Awesome. OK, so if we wanted this to, instead of be sample.csv, instead we wanted this to be the full GDP percentage, let's just go ahead and change the path to, instead of data originals sample, to be data originals det GDP percentage.csv. And go ahead and save that. And if you run your program again, oops, det originals, thank you. Key error country, oh, I forgot. Before we do this, we have to go into det GDP percentage, and because the World Bank gives us information that's formatted with this random stuff at the top, just go ahead and manually delete the first 4 rows for now and save that. And then try running your code. Cool. All right, so it does the same thing. It lets us open up this file. It consumes all of this in memory. We use a CSV dictWriter to transform this first row into all of the keys we need, and to turn the value, to turn the later rows into values that are keyed on this first row. And everything becomes a dictionary, and then we're just pulling out the country code and the 2013 data for each dictionary. Does anybody have questions? Cool. OK. So now we know that we can just read stuff, we can refer to individual values from this, But let's say we want to actually clean this up programmatically. Like we know that we are in this file. If we have a look at this data, data originals, debt GDP percentage.csv. Okay, so we have this stuff. We don't need that. Country name, country code, indicator name, central government debt, indicator code, all this stuff. Okay, so let's say we actually wanted to do some analysis on this, and we decided that we only need the data of years, and we need the country code. But everything else we don't need. It's just adding a lot of extra fluff to our file. And so what we would do is we would want to delete these columns. That's something that you can do manually before you do your analysis, but let's see if we can do it programmatically. So that's what we want to do. We want to delete the columns that are not useful to us. And if you think about it, we don't actually want, like, let's say we got this data downloaded from the World Bank, but we don't want to mess up what we've downloaded. Or let's say we've got it sent to us and we don't want to mess up the original. So in order to start cleaning the data, we want to write a new file and keep the original the same so that if our program messes up, we haven't done something irreversible. So in that case, we want to write a new file, and we're going to store it in the outputs directory that we have here. And it'll be a new file that's exactly the same, except it won't have the country name and it won't have the indicator name, for example. Make sense? Cool. Okay, so for writing a new file, for reading a file, we use the CSV dict reader. For writing a new file, we're going to use a class called the CSV dict writer. And that is, let's see here. You can copy and paste the code from the cheat sheet and put it right on top of the starter.py. Okay. So what's different between this and the code we had before? The biggest thing is here, the csv.dict writer. We have both a reader and a writer. And other things that are different is we have this new fields thing that we'll get into a second. And also we have two file pointers. One is opening up the data originals debt GDP percentage file, but one is opening up a new file called data output debt GDP percentage. And we're opening it up instead of with read permissions, with write permissions. And so what is this CSV? So the big three things are we're using a CSV dict writer, not just a reader. So we're going to write a new file. We are making this fields thing, which we don't quite know what it is for yet. And we are opening up a new file pointer with writing permissions. Okay, so first off, what's this dict writer thing? We can do a quick Google search for Python CSV dict writer. And what does it do exactly? Okay, so we know that a CSV dict reader lets us take a CSV file where the first column is the headers, the first row is all of the column headers, and turn that into a dictionary where the key is the column name and the value is all the values of the CSV. A dict writer is something what does it do? Create an object that operates like a regular writer but maps dictionaries onto output rows. The field name's parameter is a sequence of keys that identify the order in which the dictionary is passed to the write row method and are written to the CSV file. Okay, what does that mean? Well, if we look at the sample code over here, down here, we're creating a new CSV dict writer. It's passing in a file pointer like we knew, and field names equals field names, so it's a row here. And then we can say for each writer.write row, and we give it a dictionary where one key maps to one column header here, one key maps to one column here. So the dict writer row just lets you say, what are the columns you care about? And then pass a whole bunch of dictionaries to it. And we will use that dictionary to write new rows onto your new file. Does that make sense? So if we run this starter code right now, let's see. So this is what we're doing. We're saying we have this dict writer. We're passing it in this write permissions file pointer. we have fields, which is an array of columns that we care about. Okay, and what that is we care about country code, right? We're getting rid of country name, we're getting rid of indicator name, but we care about country code, and then we care about all of the years. We want to make sure that we bring over the years into our new CSV file. So we say for everything in the range between 1960 and 2015, turn that integer into a string and add that to this list of fields. So at the end, this is a list that looks like this. Oops. And on to 2015. So fields looks like this. It's getting passed into here, and then we're using that, and we are going to write new rows to our file that look like that. And then we say for every row in the reader, so we're traversing the original row, take that dictionary and write it to our new file. All right, so let's go ahead and run this, make sure it works, and if you guys have any questions, you should ask them. So Python star.py. Let's see here, make sure our output is blank. Now if we look at this guy, then it is the same CSV file, but without the indicator code and the country name. And we should be able to open this up in Google Drive. So if I go to Google Drive, I go to where this is, Documents. Oh, thank you. And I do a double check, and yep, it looks like it only has the columns I care about. And did it give us, yeah, and it gave us the data that we wanted from the original. Okay, so go ahead and try that yourself, and please ask any questions if you have any. Oh, I uploaded mine to Google Drive. Yeah, I went through the interface. You can use Excel if you want, but I don't have Excel. I just have numbers, which is not very good. Guys? Cool. Raise your hand if you were able to get this to run and write a new file and validate that it works. Okay. Raise your hand if you were not able to get it to work. All right. Do you need an extra second, or is there a question we could answer? No problem. And also, you can copy code directly from the cheat sheet if you would like. All right. While we're just taking an extra minute or so, looking at the code, let's see here. We know what this does. We know this is the dict reader. Extra is action. You don't have to worry about that right now. It's just basically how to write the dictionary if there's extra fields from the reader, from here, that aren't addressed in the row of fields. The writer we went over, and then we wrote row. Does anyone have questions about what the code does? Mm-hmm. His question is, does write header take any arguments? No, because our writer already knows what the header is based on getting fields passed to it.
So if you didn't use write header, then the header writer wouldn't be there.
I believe so, yeah. Her question was if we didn't call write header, like it would just be the entire same thing in the right places, but without columns. And that sounds about right, but we can try it. So if we save this, and I delete this, so right now it's country code, all the years, and ABW with a lot of information, or lots of commas, ALB with lots of commas till we get to 35. And then if we go to starter and we comment this out, and now when we look at this, is exactly like you said. It's just the same thing, but without the column, or without the header. Cool, okay. So what did we just do? We downloaded some data, and we looked at it in a pretty interface first. It looked like just this big table with extra stuff, and we decided we want to take the same CSV sheet, but not have all these extra columns. So we rewrote it using the CSV dict writer class to only include the fields we care about. Okay. Now, there's one thing that we did manually, which is bothersome, which is deleting the first 4 rows of the column. So what if we could just do that automatically so that next time when we download information from the World Bank, we don't have to tell some intern to delete those four sheets. They can just run our program. So that's the next thing of sample code. I'm just going to copy it and paste it from the cheat sheet. And you can go and change your starter.py as well. And we won't go over the code yet, but if you go to your originals .gdp percentage file, hit undo until you get this extra stuff back, and double check the output. Let's delete this. And so now, if our program does what we think it should do, then when we read it, it will let us run this file and also get rid of this whole thing. So let's run this, success, and it looks like it did work. It ran this. So does that work for everybody who's following along? Okay, so what does this do? Well, the first line's the same. We open up an freader, then we have the skip lines. We skip 4 lines. Okay, we'll go back to that in a second. Then after that, everything is the same. We have the writer, we have the fields, we have the dict writer, and we write rows. So what's a skip line do? It takes the file pointer, and it takes the number of lines we want to skip, and we say, first we skip 4 lines, and then so remember how we said this freader is just a file pointer? We don't have this entire data sheet in memory. All we know is that we have this data sheet, and we're keeping track of where we are and traversing it. So before we do any of the CSV reading, we're just going to move that pointer down by 4, and then we're going to go on our pretty way. Does that make sense? Cool. All right. Raise your hand if you were able to copy and get this done and save the output like you wanted. Cool. Okay. Okay, so let's see. So we're these researchers. We got some raw World Bank data, and we were able to get it to be just the columns and rows that we wanted. Great. What would we want to do? Like, let's say we also care about doing this not for debt, but also for inflation, which is from the World Bank, and it's in the same format. It has these 4 rows, and it has all these extra columns that we don't necessarily care about. And let's say there's just many, many World Bank sheets that we want to do the same thing for. What would we have to change in our existing program if we wanted to do the same thing for a different sheet of data? Yeah, exactly. This would just have to be a new file. So we can copy, we can just do this for the same thing and just keep on going. But since we're computer scientists, we are going to write a function that'll do this, and then we can call it and just have the file name be an argument to our function. So that's what we do in the next thing in our cheat sheet. So let's go ahead and bring it over here. Okay, so how is this different from what we had immediately before? Let me pull this up slightly here, and then compare this to what we had before. Okay, so we had skip lines, freader, fwriter, but now what's different is the majority of our code is in the second function called standardized tables. And it takes a path to, like you were saying, the different files. So we say our input for inflation is data originals input, and we feed this in here. And then our output is the same thing, where we want the file to go when we're done with it. So we just save those two paths, and we call standardized tables with the input and the output. And then we can call this function over and over again without having to copy and paste a different freader input into here. Does that make sense? Yep. Nope. Awesome. Cool. So now, if we run this code and we get rid of the output for debt, and inflation is just a placeholder still, if we run this code, we are standardizing inflation and debt, so we should get the shorter, cleaner files in our output file for both inflation and debt. Cool, success. And it looked like that worked for both inflation and debt. Cool, all right, so I'll give you guys a minute to do it as well. All right, raise your hands if you're able to run this code and generate the files for the two different types of data. Okay, sounds good. All right, so okay, so we're able to write a function, so now we can run the same cleaning and prepping on as many different World Bank files that we want. So we went from opening this up in Google Spreadsheets and needing to manipulate this manually to doing it programmatically with a dictionary writer. Then we are able to make it into a function that we can call as many times as we want. But now let's say that we're researchers and we have a buddy down the hall that also works with World Bank data, and we want to share some of this code with them. Like, would we just take this and just say, oh, here, just take this function and copy and paste it to what you're doing? That's something you could do, but the more reliable way of doing it would be to make a module. And same thing is, like, even if you wanted to look at the World Bank data for every quarter and you wanted a running job that could fetch the World Bank data and do this work on it, you wouldn't want to physically cut and paste this code into the scripts that you write every quarter. You'd want to have something that you could import and reuse really cleanly without worrying that it would change, that you would accidentally change it as you cut and paste it around. So instead you want to write a new module. So in that way, your starter.py file only needs to import the module the same way we import the CSV module and use it individually. So what do we need to do? Make a new, or actually you guys can open up the World Bank standardizer.py file and go ahead and do Command A and delete it and copy and paste the new thing in the cheat sheet, which makes this a module. And we'll come back to this later, but in your starter.py file, it'll be much smaller now. And go ahead and copy that. Command A, delete everything, and Command this. Or sorry, and paste the next thing from the cheat sheet in. So if we look at the star.py file, it does a lot of the same things. It declares the file pointer for the inflation data and the file pointer for where you'd want the prepped sheet to go. It does the same thing for debt. And then it calls standardized tables, calling these variables. The difference is we're now importing this World Bank standardizer module, so it's an external place where all that World Bank reformatting code lives. And the other thing we have to do is instead of, before we were just saying standardized tables and the functions were defined up here, now because we're importing them, we have to instantiate a new class that knows about these functions and call those classes off of this thing that we've imported. And then if we have a look at the thing that we moved all of our formatting code to, it's in a class. So the main things we had, this is all of this is the same. But the only thing that changed is it's a class that can be instantiated when we call it. And also because these are methods on the class, we have to, they're instance methods, we pass self in as arguments, and also when we call skip lines, it's a method that's also within the class. But aside from that, this is all the same code that used to be directly within starter.py. All right. So now, if we delete the two output files and we run starter.py as it is with this new importing, it should give us the same cleanup stuff. But the difference is, instead of giving your friend down the hall an email of starter.py and saying, cut and paste this World Bank stuff, you can just give him or her this entire class. They don't even have to edit at all, but their starter.py file can just import it in, and as long as you have this entire file untouched and it's visible within your project file, then you can run it. All right. Does anyone have any questions? Or did anyone get a little bit behind and can use some help getting on track? Cool. Okay. So one thing to notice is the boundaries of what you'd split out into module and what you wouldn't. Notice that the starter.py file has all the context about where your file location is, and it just uses that as arguments to the table. So if this is something that's your project and your buddy down the hall has a totally different project and he's storing all his CSV files in a different way, that shouldn't matter. The World Bank code should only care about World Bank format, and your own starter.py script has all the context about where your CSV files are located. And then this stuff can get reused and reused regardless of how you're setting up your folders. Okay. Let's see. So we have a break at 3 o'clock, but it looks, so I'm going to go through the part that was specified in the break, and Actually, why don't we take like a 5-minute break? We can break again at 3. And then I want to get just a good sense of where people are and if it's too slow or too fast. Feel free to ask me questions and I'll be also circulating. But let's meet back at 2:25, so a really quick break. Sound good? So let's get started again. All right, so I got a good sense from here about where everyone's at and who's following along, who's following the sample code. So let's get back to this. So what did we do before break? Before break, we were writing new writers. We were writing new files that took our original World Bank files, got rid of the first few lines of cruft, and got rid of the columns we don't need, and wrote them into this new output file. And then we took that code and we made it a method so we could call it repeatedly with different file names. And lastly, we took that method and we made it a whole separate class, a whole separate file that could be imported and used repeatedly and in different contexts. Sound good? Cool. Okay, so that's what we did with all the World Bank data. Let's say we wanted to make one big master table of, World Bank data for inflation, World Bank data for debt, but we also wanted to look at credit ratings to see how these things are all related to each other. So The Guardian has, well, if you do a Google search for sovereign debt credit ratings, The Guardian newspaper had this data sheet that took each country and how the different credit ratings rated them in terms of debt. So you've got Israel, which is A+, and we've got Poland, which is A-. So let's say we wanted to make one sheet that was comparing this with the data that we have from the World Bank. That's something that we can do, but if you can imagine, what's something that makes this set of data different and hard to compare with the World Bank set of data? Yeah, exactly. Here they use 2-digit country codes, and here they use 3-digit ISO codes. So if we had to match them, we'd first have to convert them in order to make them work. So, okay, so that's something we have to do in this cleaning set before we can make them into one big set of data. Okay, so how do we do that? Well, you can just do a Google search for Python standardize country codes. And the first thing you get is this package called PyCountry. And see, okay, what does it do? It provides the ISO databases for these standards. Okay. It looks like you can do something, Germany equals pycountry.countries.get, and you look up one code, okay, and it gives you this object. And from that object, you can pull off the alpha 2, you can pull off the 3-digit code, you can pull off all these names. So it looks like something we want. And it's hosted by the Python Software Foundation, so hopefully it's not some random library. It's something that is pretty well written and pretty reliable, so we can see if we can use it. So let's go ahead and try it. I was able to download this doing pip install PyCountry. And some of you guys might not have pip installed yet, in which case we'll have to get pip for you. But go ahead in your command line, do pip install PyCountry first. And if you're not able to do that, raise your hand. All right, raise your hand if you were able to install PyCountry. Cool, we've got a couple people still working on it. And if you don't have pip installed, then go ahead and if you don't have pip installed, just do a Google search for get pip, and if you don't have pip installed, then you can download this file called getpip.py and then run python getpip.py. Okay. All right, and I'm gonna move on, and then if you have problems getting PyCountry, I'll circulate and check in with you guys. So let's just validate that PyCountry does what we want it to do. In the starter.py file, I'll go ahead and comment out everything for now. And let's just see what this guy does. So go ahead and take okay. All right, so from the cheat sheet, go ahead and try out this thing that uses PyCountry. So we're saying we want to see if we can print out the alpha 3 for Germany, only knowing the alpha 2. So copy that in and run it, and it looks like it works. So can we do the same thing once we have Germany, print Germany.alpha2. Cool. All right, so we have one CSV file that has countries in alpha 2, another CSV file that has countries in alpha 3. So ideally what we want to do when we're going through the alpha 3 countries is whenever we see an alpha 3 country, look up what its country is, then look up what its alpha 2 value is and rewrite the rows using that. Make sense? Cool. All right, so we have this module. We validated that it seems reasonable and it does what we want. So we want to write a function that takes in alpha 2 values and alpha 3 values and gives us out alpha 2. So in our cheat sheet, and Chrome was very slow for me, so I'm just copying it from Markdown directly. Okay, so we validated that it seems to work, and then we want to write a function that will translate country code. So we pass in the alpha 3 code. We use the alpha 3 code to get the country, so we get the Germany object, and then we return the country's alpha 2 code. And that's well and good, and if for some reason there isn't a country, like DEU doesn't return us anything, for now we're just going to put in asterisks. So we'll have rows that have asterisks if there is no result found. Does anyone have any questions? Okay, so we have this method that uses our PyCountry module that turns alpha 3s into alpha 2s. So how will we use it? Okay, so if we look at our World Bank standardizer, as we're going through each row in reader, that's saying take every row in the existing CSV file and each row is a dictionary. Take that dictionary and write it to the written file. Right now it's writing down the exact same row for every field that has columns there. So instead what we want to do is replace row country code equals, and then here we call self.translate country, I think. And then we'd say the existing row country code, I believe. But let me go ahead and copy it off of the cheat sheet. Okay, so we have our new translation method down at the bottom here. And yeah, we've basically said for every row and reader, before you write it to your writing file, you replace the existing country code with the translated country code. And so now when we run this debts DDC percentage file, instead of replacing everything straight up with ABW in the output, these should all be 2-digit country codes. So let's give that a try. Oops. All right, it worked. And now we do see that the output gives us 2-digit country codes. Cool. All right, so I'll give people a minute to catch up. Please raise your hand if you have any questions. Yeah. Yeah, yeah. Does that delete the line? I think I know what you mean. So he asked, every time we run this program, we're skipping 4 lines. Like, doesn't that sort of mess things up? Here, every time we open this, we're skipping lines. So what's happening is whenever we call standardized tables from starter.py, we're saying standardized tables, here's the inflation one. Standardized tables, here's the debt one. When we call that, it gives us the original file path, and we open it as if for the first time, and we skip lines, and then we do the rest of our work. Then the second time, when we call starter again, and we call standardized tables again, it starts at the top of the file again. All right. Raise your hand if you were able to follow along with the translating country codes back into 2 digits. Cool. Okay. Sounds good. Okay. So now we have all the World Bank code only having the columns we want. And we have it in country codes that match the ratings one. So now what I want you to do with a partner is see if we can do the same thing with the ratings code. So if we look at the ratings code, we have the 2-digit country code, so that's good. And let's say we only want output files of Moody's, S&P, and Fitch. But we don't want the outlook. Like, we don't want the stay or the sell or whatever. So we don't want these extra columns. What would we do? What would we need to do if we wanted to write a new class standardizer that was for this format of files instead of the World Bank format of files? Like, if we think about what we did for the World Bank format of files, what all would we need to do for ratings? Do we need to skip the first 4 columns or, first 4 rows or anything like that? Oh, so let's say our input file was this credit ratings file instead of the World Bank one. And let's say we want to create a class like the World Bank standardizer that would let someone consume this table and generate a file that only had the countries, the ratings, but not the outlook. Uh-huh. Yep. Yep. So he said exactly the thing. Make a fields that specifies the one that we talked about, ISO code, S&P rating, Moody's rating, and then feed that into our CSV dict writer class to do the same thing. Does that make sense? Cool. So we can go ahead and implement that. It's already written here, so So let's see here. So just like you said, you have the dict reader. We have the field. It's a lot simpler this time because we don't need to get all of the years. But then we take these fields and we feed it into dict writer. And we write the headers. And then very similarly, we just go ahead and write all the rows. And then if we wanted to use this, then let's see here. Then we'd have to make this the rating standardizer. Okay, so now we're using the World Bank standardizer to do all the things we did before. Then we're making a new rating standardizer that we've imported here, and we're giving it the same paths that we need. And the rating standardizer also has a standardized tables method right here that does things knowing the context of the Guardian tables. So now when we run this, it should also create an output file for standardizing tables about the ratings. So we run our starter.py. Let's see. Standardized tables, credit input. Credit ratings 2, 3. See. And it does create the things with just the ISO code, the S&P rating, Moody's, and Fitch. Cool. Was everybody able to follow along and use their starter file to use the ratings class? What's it?
I would say it's a little bit confusing. You have two standardized tables that do different things.
Yep. Yeah. This guy versus this guy? Yeah, you have to make sure you're calling on the right one. All right. Were you able to get the ratings one to work? All right. Well, is everyone that's working on that able to get the ratings one to work on their file? Awesome. Sounds good. Okay, so now we have a table completely standardized of the credit ratings, and we have matching tables for debt and GDP percentage. So this is something that there's no cheat sheet for, but work with your partners, and we can do this. We have a whole hour left. If we wanted to take the three different types of tables, and we wanted to make a master table that had the country, the three different types of ratings, and inflation and GDP for, let's say, 2012 and 2013. We want to write a whole new file that has those columns that's merging some of that data. What would we need to do? Like, what are the meta steps that we need to do? And then we can work in smaller groups to execute it ourselves. Okay, let's say we have this output that has the inflation for all of these years. And then we have this other file that has this. Let's say we wanted to make one big table that has all of this information for each country. So the rows would be, the rows would be each of that country, and the column headers would be these three ratings, and then debt for 2013, for example, inflation for 2013, in debt for 2012, inflation for 2012. So in essence, we're merging these two tables, but we're not doing all of the years because that would be ginormous. So what would we need to do to make one big table that looks like that? New class. Go ahead. What's your thought? The two classes that take the two files. Okay. Okay, sounds good. Sounds good. So we'd have a new class like called CSV merger or something like that that takes the two file pointers. And then what would it do? Yeah. Yeah, that's a good. Yeah, that is a good point. So he said the ratings are not pinned down to the year, whereas the debt and inflation is. And that's something I didn't know myself. But if you look at the credit ratings page in Wikipedia, it looks like the credit ratings page change. The credit ratings change at all these different times whenever there is an update. So we can like if we just say the ratings for Brazil is B or something, it'll say last changed. October 2012. The credit ratings for the United States is A, I guess, last changed, 2000, whatever. And so because of that, because they're changing all the time, it's like this is the most up-to-date as of 2013, which is when this Guardian article came out. So because of that, it makes sense to look at like 2013 and 2012 data, I guess. Cool. So something that I will leave as an exercise to you guys in small groups is doing this, making a table that merge, and it sounds like your steps were make a new class, CSV merger class, for example, and the class would have a method merge that takes in clean file 1, clean file 2, and clean file 3, because there's the debt and the inflation, and the Moody's one is separate, right? Because you said 2, and I went along with you, but there's actually 3 different types of clean files. Sounds good. And then what we do is we'd probably read reader to read the contents, build, and then we like want to build up a dictionary that has the fields that we want for each row. And then we'd write that to a new file using dict writer. Okay, so these are the general steps. I think the merge step also needs an output location. So these are input locations for the clean files and then a new output location. And then we generally use these steps to merge the data together and write it row by row. So that's something that I'm going to circulate, and I hope you guys will work on it. I will sit with you guys and try to work in groups of 2, or you can pair up with another group. We have a break at 3, so come back and we can work on this together. Everyone. Okay, so starting at 3 o'clock, we have a 20-minute break, and we're going on till past 4 o'clock. I invite you to come back, and we'll treat the second part after the break as more of a study hall. I'd love to implement this merging class with some of you so we can work in small groups and do that together. After that, if you guys have anything else that you're working on personal projects, I'd be happy to look at them too. But also feel free to cut it short early if you don't feel up to implementing these. But anyone that wants to can stay and write this together. Cool. See you after the break. Oh, what's your question? Matching, are you talking about the implementation for this? Interesting. And I'm not sure which part, but I want to answer your question. So. Are you talking about, oh, you mean in the translate countries, in this part? Here, would this take a long time? Well, right now, here we're just traversing the reader. So we're just, 40,000 rows in your table.
That's pretty easily done.
If there's, yeah.
40,000 rows, that's very easily handled. We work with, I mean, performance law, it could take a little couple of seconds. Not million, but I think for 40,000, it'll take under a second. Don't take long. Try it for yourself.
Yeah, like some operations, it will matter how big it is, but for something like the file pointer, for example, it just moves down, so it doesn't matter how big the file is, I don't think. So, for the next hour, we are going to work on writing a function that will create this merged tables of all the countries. And there's lots of thorny issues we have to deal with. So I want to take a vote for how we want to do these, whether we want to work in small groups together to do them, or whether we want to do them as a big thing like this with me typing and sort of taking suggestions from people, which could either be great or it could be messier. So if you would rather do it sort of on your own or in a small group, raise your hand and I'll circulate, but you're doing it on your own and we'll share at the end. So if you'd like that option, raise your hand. 1, 2, 3, 4, 5. Okay, and if you want to do it in a big group, raise your hand. 1, 2, 3, 4, 5. Awesome. So why don't we have a big group gather like there? We could just be our own small group together, and we'll work, I guess, here, because I have the display. And then everyone else that wants to work individually, go towards the back of the room and pair up. You know what? Why don't we have everyone that wants to work as a group of 5, the big group people, why don't we just be a big group together? And we'll meet there, since there are more people raising their hands there. And all the people that want to work individually or in small groups of less than 5, just migrate over here, and you can work together in smaller groups. And I'll check in and see how people are doing. We can share answers later. Sound good? What's that face? Okay, so yeah, either choose to work in a small group or individually, or if you want to work in a big group with me, I'll meet you guys over here.
output file, and we used the dict writer to write our output. And what we did here is we actually took that country list that we created, the two-letter country identifiers, and with each one you see here 3 iterations. Those correspond to the 3 input files, the clean data sets that we had. The first one was the credit reader, and what we did for each one was we iterated through the list of country identifiers that we created earlier, and then we just if there was a match in the file, basically with that 2-digit identifier, we created a new dictionary called new row, and whenever there's a country match for that particular country, we got the information for the S&P, Moody's, and Fitch from the first one, and at that reader we got the 2012 and 2013 debt, and then in the last one we got the inflation information from 2012 and 2013. The whole concept behind this was it was an iteration through all 3 of the input clean data sets, and we did a search basically for each identifier, and then finally, once we had this new row dictionary set up for each, we actually at the end we printed out the row with the writer. So basically, it was an iterative approach. Basically, we created our list of identifiers, and then we iterated through each one when we found a match for each input clean data set, combined them into a new row dictionary, and then printed them, and then wrote them all out. I think hopefully that's explained it cleanly enough there. So, anyone? Okay. Oh, the seek. The reason why we did the seek, let's see if I remember this correctly, is as we iterated through the files, the seek gets you back to the top of the file, because otherwise you're dumb. You read through the file, and then it's not going to find anything because you're at the end of the file. So the seek gets you the seek 0. I guess that corresponds going back to the first line of the file. I guess you could set that to another number and go seek 15 and go to row 15 or something like that. So, yep. Anything else? No, no. I would imagine if it was a long, big data set, it might be take a while. So, yeah. All right.
Are there any other questions?
All right.
Someone else up here, so even if you don't have it done, if you think you're close and it can help you, there's volunteers.
Here you go. Got the microphone right here. You're next up. Next contestant.
Can I just explain what it is that I'm trying to do? Huh? Can I just explain? Or do I have to hook it?
You have to.
Okay. Oh. Oh boy, I have to know. Lucky me. So I have a no MacBook. For some reason, they keep changing ports. But in any case, basically what I tried to do is. Oh. Okay. So basically, what I tried to do initially, I didn't know, that it was just written that the one of the definitions, one of the functions would just take 4 or 3 files or 4 files. So what I did was I just created a list of all those files, file 1, file 2, through 4, and then I said, give me the debt path if it is in my list of files. So, you guys indicated like output, like debt output, but I didn't know that that's the kind of game we were playing. So I just went ahead and created a list comprehension and just indexed 0 for the debt. If the debt is found, it gives me the path of the debt. If the credit is found, it gives me the path to the credit. So with that, I kind of, I use the same technique to basically go, like, select 2013, 2012, country code as my fields, and then open the file. Only selected those for every single one of my, for the debt and for the inflation. So at that point, I had 2 new files, one for debt and one for inflation. And they had, each of them had 3 columns: country code, 2012, and 2013. And with that, I kind of wanted to play, I am still trying to figure out how to basically create a dictionary, but I wanted to change the names, though. I want to change the names of the columns. So say debt, like debt country code, and then debt 2013, debt 2012. And then go to the inflation file, do the same thing. Evidently, that's going to take a long time. So I was kind of trying to figure out if I could, by creating what's called a default dict, like go into the collections and find a default dict, that would basically take, for every file I open, I take the header and make it I take its headers, because I changed the headers. Now they wouldn't repeat themselves. So I open a file, I take the headers, and I create those guys as my new keys for my dictionary. And once I do that, I'll just iterate through every single one of them, combine them. So I iterate the second line of, say, inflation. And while I do that, I have it held into a variable. I go into the second line of inflation, and I combine those 2 guys. And then I do the same thing for credit. I go into its second line. Then I combine that with all the 2 previous ones. Then I put that into my default dict. And then I move to the next thing. So you see, like, it'll be like opening 3 files and then going line by line, combining every single line in those what's called, because initially I'm thinking that all files have the same order of countries. Correct me if I'm wrong, but so that's.
You're going through each of the files and combining the 3rd line from every file.
Yeah, so 3rd line of credit, 3rd line of inflation, then 3rd line of debt. Combining all of them and putting them into one dictionary that'll have as its keys country code for debt, country code for inflation, country code for ratings. So in the end, you'll have repeated country codes. You'll have them 3 times. All you do is just drop 2, and then I guess you're all set. But no. I was still trying to figure out how to change the names of the files. I could have done it with bash just directly on my terminal, but I thought that'd be cheating because we're at a PyCon. But yeah, that's kind of where I was stuck. I was trying to figure out if I could do it from Python, use the OX module, just do OX system, os.system, and just use bash script. And that gets done pretty quickly with bash, but I kind of got stuck and heard you guys finished, so I kind of, just all my courage and.
Let's look at it after this. I mean, I'll stick around. Whatever. Yeah, we can look at it and see if you can finish your presentation.
Okay, but it's probably going to be really slow.
That's fine.
All right, well, that's what I had. I hope it made sense.
Yeah,
But,
so does everyone understand what he was doing? He was opening the 3 different files, grabbing the 3rd line from every file and merging them together.
yeah. So, yeah, first I created, for the debt and inflation, you needed to have a file that only had 2012 and 2013, yeah. So after that, then I would open my newly created files along with my credit file and just
go row by row, merging all of the rows into, say, a list, and then just appending that to my default dict, which would take everything into, which would take everything and just create a dictionary. And that dictionary could be basically turned into a tabular form of data, which I work with. I work with pandas, and that's why I really struggle with this, because when I looked at the data set, I just went, why not just use pandas and import it? But yeah, but this was fun for me, just learning the abstract aspect of uploading data every day. So.
Of course, the challenge you have with your particular method is you need to make sure all three of those files have those country
Order. Now that is a challenge, but it's also, well, I kind of looked at like maybe the first 10 lines, and they kind of looked the same, so I just went with it. I could totally be, messing things up, and I wouldn't know, because if you finish merging, it'll always look like, because you don't know what country has what year and what number for inflation or debt. So it's kind of tough to tell, like if you're doing it right. But again, if I was to do it in pandas, it would just be like a simple join on the country code row, and then you'd be done. But this is, I don't know, not a pandas tutorial.
So the question was about the solution that had the seek in it so the reason why it didn't perform well was for each row, basically for each country, we have to open up all 3 of the clean files, go through all of them in order to find the match for the country, and then go back to the beginning of the reader because it's a file pointer. So that's just a lot of looping that I'm sure there's a better way around. All right, well, I think this is the end of it. Thank you guys so much. This has been so much fun for me. And I hope that you learned something about, I don't know, making modules over your code and using it in your daily work, or at least something that you can use in the future. Thanks. Have a good PyCon. Oh, mine.